Okay, now in this video, we're going to talk about solving log equations. So in the previous video, we solved exponential equations, and when we solve exponential equations, we rewrite it in log form to solve. Now that we're trying to solve log equations, we're going to rewrite in exponential form to solve for x. So the general procedure is, the first step is you want to take all the logs and move them to one side and condense. So you want all logs on one side and everything else on the other. Then once you condense it into one log, you want to write it in exponential form. Once you write it in exponential form, then the next step is to solve for x. Then the last step is to make sure you check your answer because of domain restrictions. Remember, you can't take the log of 0 and you can't take the log of a negative number. So if you end up with a solution in which you plug in a value for x that would cause you to take the log of 0 or a negative number, you have to eliminate that from your solution. In this example, we only have one log, so we don't have to worry about getting all the logs to one side. However, we do have to isolate that log. It's already condensed, but we do have to divide both sides by 4. So I'm going to take 12 divided by 4, and I'm going to get 3 on the other side. So now I have it set up so that I can put it in exponential form. This is what we want before we put it in exponential form. We want one log, no coefficients in front, just log of something is equal to something else on the other side. And once we have it set up like that, then we can put it in exponential form. So exponential form, my base is 3, my exponent is 3, and I just solve for z. So z is going to be 27 because 3 to the third is 27. Okay, and in example 2, this is what I need to isolate. I don't have multiple logs here that I need to condense together, but I do need to get that log by itself and everything else on the other side. So the first thing I'm going to do is subtract 15 from both sides. So I have 9 minus 15. That's going to give me a negative 6 on the right-hand side. Then I'm going to divide both sides by 3, or negative 3. So now I have log of 9x plus 1 is equal to 2. So now I have it set up where I have log, just one condensed log, is equal to everything else on the other side. So once I have it set up like this, I'm going to put it in exponential form. Now, even though it's not written in there, I know my base is 10. So when I write it in exponential form, I'm going to have base 10, raise it to the second power, and this is equal to 9x plus 1. So I have 100 is equal to 9x plus 1. Okay, so now I got to finish solving for x. So I'm going to subtract 1 from both sides. So x is going to be 11. Now if I go back and double check to make sure this works, I'm going to take that 11 and plug it in for this x. And I have 9 times 11 is 99. 99 plus 1 is 100. And I can take the log of 100, so that's fine. And then when I have 15 minus 3 times log of 100 is equal to 9. We'll keep going and check. This is equal to 2 because 10 squared would give me 100. So remember, log is the exponent. My base is 10. So 10 to the second power would give me 100. So I have 15 minus 3 times 2 is equal to 9. And that gives me 15 minus 6 is equal to 9, and that works. Now, if for some reason I got x is equal to negative 11, and I go to plug it back in, I would be taking the log of a negative number. And if that was the case, then I would just say that that's not part of my solution. So you always should go back in and check to make sure that your answer works because of your restrictions with logs. Okay, next example. Now here we do have multiple logs. So I need to move all my logs together to one side and condense them. So I'm going to subtract log base 14 of 12 minus 4x from both sides. Now I'm going to condense it. Now that I have all my logs on one side, I'm going to condense it. And because this is subtraction here, I'm going to use the quotient rule. So I'm going to rewrite this as log 14, and I'm going to set this up as a quotient. 4x minus 4 goes on the top, and the bottom would be 12 minus 4x. So now I have this set up where I have one condensed log on one side and everything else on the other. So now it's time to put it in exponential form. So exponential form would be my base is 14, my exponent is 0, and I'm going to set this equal to 4x minus 4 over 12 minus 4x. And then I'm going to solve for x from here. Now 14 to the 0 power is 1. I'll finish it over here. And now when I go to solve for x, I can either multiply both sides by 12 minus 4x, or I can cross multiply, whichever you prefer. It doesn't matter, however you look at it. I'm going to use cross multiplication. When I do that, I get 12 minus 4x is equal to 4x minus 4. And I'm going to keep going and solve for x. So I'm going to subtract 4x from both sides. I'm going to subtract 12 from both sides. So x is going to be 2. Now we have to go back in and check it though. So if I take and plug the 2 back into my original equation, I have 4 times 2 minus 4 inside the parentheses. And then on the right-hand side, inside the parentheses, I have 12 minus 4 times 2. So I have log of 14. 8 minus 4 is 4. And then 12 minus 8 is 4. So this works. Okay, next example, example 4, we have multiple logs again. So I want to make sure that I have logs, all my logs together on one side and everything else on the other. So I'm going to subtract natural log of x squared minus 7x on both sides. Now I am going to use the quotient rule to condense this. So I have the natural log of negative 3x over x squared minus 7x is equal to 0. So now I have one log condensed on one side with everything else on the other, and I'm going to put it in exponential form. Because this is natural log, my base is e, so I'm going to write e to the 0 is equal to negative 3x over x squared minus 7x. E to the 0 is just 1, so I have negative 3x over x squared minus 7x is equal to 1. And then again, you can either cross multiply or multiply both sides of the equation by x squared minus 7x. It just depends on what your preference is. I'm going to use cross multiplication, and I get that negative 3x is equal to x squared minus 7x. Okay, and now I have, notice that this tells me I'm now solving a quadratic because this is a degree 2. So I'm going to move everything to one side and either factor or use quadratic formula to finish finding x. So I have x squared minus 7x. I'm going to add 3x to both sides. I have x squared minus 4x is equal to 0 when I combine the negative 7x and the positive 3x. This factors very nicely. So x could be 0 or x could be 4. Now we have to go back in and plug it in to check. If I take 0 and plug it into the original equation, I would have the natural log of 0 is equal to the natural log of 0. Remember, I can't take the log of 0. So this one is out. I can't use that one. If I plug in 4, that also doesn't work because if I plug in 4, that's going to give me the natural log of negative 12. And I can't take the log of a negative number. So this one's also out. So in this example, there are no solutions. Okay, next example, example 5. I have multiple logs, so I want to combine them together on one side. So I have log of 9x. I'm going to subtract log of x squared plus 5x from both sides. So now I'm going to combine these and condense them using the quotient rule. So I have natural log of 9x over x squared plus 5x. So now I have it one log on one side, one condensed log, and everything else on the other. Keep in mind that the last few examples we've done also, we've gotten 0 on the right-hand side. It's just coincidental that these are the examples that I chose that we got 0 on the other side. It might not necessarily always be 0 over there, so keep that in mind. Okay, so we have a condensed log is equal to 0. And so now we're going to put this in exponential form. So my base is e because it's natural log. My exponent is 0. And I have 9x over x squared plus 5x. And e to the 0 is equal to 1. So I have 1 is equal to 9x over x squared plus 5x. I'm going to use cross multiplication to keep solving for x. So 9x is equal to x squared plus 5x. If I notice, this is a squared, so I have a quadratic now to solve. So I have to move everything to one side and either use quadratic formula or factoring. So when I subtract 9x from both sides, I get x squared plus 5x minus 9x is equal to 0, which gives me 5x minus 9x. When I combine that, that gives me a minus 4x. And this factors nicely. I get x is 0 or x is 4. So we have to check them though. If I plug in 0, I get the natural log of 9 times 0, which is 0. And I can't take the log of 0. So this one's out. I can't use that one. If I plug in 4, that gives me the natural log of 9 times 4, which is 36, is equal to, and then on the other side, I have 4 squared, which is 16, plus 20. So I have the natural log of 36 on the other side as well. So 4 works in this case, but 0 doesn't. So x equals 4 would be my only answer. Okay, in example 6, I have 3 logs, and I want to combine them all together on one side. So my first step is to subtract log 12x from both sides. So I have log of x plus log of x minus 8 minus log 12x is equal to 0. First, let's combine this. I can combine the addition using the product rule. So I would have that as log, and then I would multiply the x and the x minus 8 using the product rule. So that would be x squared minus 8x. Okay, now I have to combine these two logs. So that would be the quotient rule. So I would have log x squared minus 8x over 12x, and that's all equal to 0. So now I have this all combined into one log and everything else on the other side. So now I can put this in exponential form. And even though it's not written in there, I know that this is base 10. So I'm going to write this as 10 to the 0, which is equal to 1, is x squared minus 8x over 12x. So now, just like the previous examples, I can use cross multiplication, or I can just multiply both sides by 12x to finish solving for x. So I have 12x is equal to x squared minus 8x. So I'm going to subtract 12x from both sides, and that is going to give me 0 is equal to x squared minus 20x. And then I can pull out my x. So x is going to be 0 or 20. So this is what we need to check. I can't plug in 0 because that would give me the log of 0 or the log of a negative number. So 0 doesn't work. But if I plug in 20, let's check that one. I would get log of 20 plus log of 20 minus 8 is equal to log of 12 times x, or 12 times 20 would give me 240. So I would have log of 20 plus log of 12 is equal to log of 240. This I would combine using the properties of logs in the product rule, and I can combine that into log of 20 times 12, which is 240. So this works. So 20 is my only answer here. Okay, example 7. I have multiple logs, so I want to get them together on one side and combine them together. So I have natural log of 8 minus natural log of 8 minus 8x, and I'm going to subtract natural log of 7 from both sides. Let's first combine these. That's the quotient rule because it's subtraction, so that would give me the natural log of 8 over 8 minus 8x. Now I have to combine these. So I'm going to take 8 over 8 minus 8x and divide by 7. So I would have this. Okay, now I have it written as one log. I have everything else on the other side, so I can write this in exponential form. My base is e, so I have e to the 0. This is equal to 1, and that's equal to 8 over, I'm going to distribute that 7 when I write this down. That gives me 56 minus 56x. So this is what I have so far. I can actually divide the 8 into all of these. Let's make it easier. That would give me 1 over 7 minus 7x. And then I can cross multiply. So I have 7 minus 7x is equal to 1. Subtract 7 from both sides. So that gives me x is 6/7. When you plug it back in, you'll find that 6/7 works. So I would just plug in 6/7 in for x everywhere. And you'll find that that works. Okay, last example. We have log base 3 of x minus 4 is equal to -3. I want to get this by itself and everything else on the other side. I already have just one log and it's already condensed, so all I have to do is just isolate it. So I have log base 3 of x is equal to, and I'm going to add 4 to both sides. So I get 1 on the opposite side. Then I'm going to change it to exponential form. So I have 3 to the first is equal to x. And then you can go back in and check your answer.